because by the time this probably goes live, it'll probably be like, it's mostly the same. It's just, it's not like wrong.
Yes.
You might be better off sacrificing some performance to get more RAM, and that's better off than like a higher benchmark score.
Whether you're a PC enthusiast or a creator, knowing how and why a PC hardware works is a great skill to have. There will be a day when you need to upgrade or troubleshoot, and knowing how your hardware utilizes the software and vice versa is such a valuable skill to have. In this video, I'll be diving deeper into the PC hardware with Matt Bach from Pugetsystems, who's part of the family who started Pugetsystems over 2 decades ago. And he has created Pugetbench that's now widely used by many of the big brands, including AMD and Intel when they are doing their product launch events. Pugetsystems is also a system integrator for thousands and thousands of creators, which puts them in a very unique spot knowing how the hardware is utilized and used by creators, breaching the gap between software and creators. They are providing the hardware. This is going to be an interesting conversation with Matt, and you'll be hearing a lot of interesting tips and understanding better how the software utilizes the hardware and much more.
Looking for a cheap way to license your Windows? Check out Whokeys through the links in the video description. Make sure to use the code TN20 to get a 30% off. Paste the license to the activation settings and you're all done. This license is for Windows 10, but you can upgrade it to Windows 11 for free. They also offer Microsoft Office 19 license. Use the same code TN20 to get a 30% off. Check out whokeys.com in the video description below.
So, quick question, offering Pugetsystems to the general market, is that like a marketing strategy?
Yeah, you're talking about like the Pugetbench, the benchmarks?
Yeah, because I'm sure most people just think of Pugetsystems as like literally a benchmark company, and your entire company has full clientele, your systems integrators with, I'm sure, massive companies.
Yeah, so the benchmarks, how they came about was actually when we started our labs department, which is basically our hardware testing and publishing division. We found that was like media and entertainment was an area where there was very little. And we're talking, 10, 12 years ago now. Mm-hmm. There were no benchmarks out there. There was no testing. There was no anything. So we saw that void and we wanted to start publishing for that stuff. And me, I'm lazy. I don't want to sit there and click buttons and sit there with a stopwatch and time things. And so, I just went and tried to figure out what is the way that I can automate this stuff. So I can click one button, it can just do it, and it can give me a result. And, at first it was very, very, very rough. I needed a lot of babysitting, a lot of finicking with it. But over time, it's developed to the point where we were getting requests from people to like, hey, can we use this? Like you have results out there. Can we use it for our own testing? That was from both hardware reviewers, but also companies like Intel and AMD and Nvidia. They've all three now are starting to use our benchmarks as part of their launch content.
Wow!
That's
which is great and kind of scary because it was like a homebrew, threw together scripts to for our own automation. But obviously there's that need, and so especially over the last couple of years, and especially this year, we've been trying to polish that stuff up, getting it so that it's more compatible, handles errors way better, more consistent on like how often things can break. Because if you use any of these applications that we test, that they can just sometimes just break on their own. There's nothing really you can do about it. But handling those errors. And I know one of the big things that's like important for you guys is that the results have a longer lifespan. Because right now, up until very recently, we've been calling them beta because of how much work we're still doing of, okay, what do we want to test? How can we test it? What can we test? Oh, Adobe changed something in their API. Now we can't do that, but now we can do this. But the big thing this year, the big push is to getting them to a full release, a 1.0 release, so they're no longer beta, and then locking them in for at least a year, hopefully more like 2, of we're not going to change the test, we're not going to change the tests, we're not going to change the scores, it's all just consistent, and like reviewers, hardware manufacturers can use it, and it'll be the same. We're probably will have to have like a beta branch because, Adobe could add something super crazy awesome to Photoshop. And like, we want to be able to test that. We don't want to have to wait 2 years, But at the same time, not every hardware reviewer needs to be completely up to the absolute latest. I mean, if they're more focused on the general tech audience, they're probably not even using Photoshop. They just want to know, hey, is Intel better or is AMD better? They got their fanboy, things that they want to, their team they're rooting for. They want to see
confirm
those bigger
their
numbers.
biases.
Yeah.
Oh, this is a whole nother conversation. But I want to know, what does it feel like to you when you see now the AMD or Intel keynotes and seeing Pugetbench scrolls like these graphs on the screen there?
It's amazing.
Because you guys like built it. And then now you're seeing these big companies actually using your way of testing things.
Yeah, it's really cool and kind of a little scary too. Just because, I mean, it's cool because, yeah, anytime you see something that you worked on and is part of something that big and massive, yeah, that's awesome. That's really cool. It's a little scary because, well, hey, what if we're not testing something that people think is real world? But at the same time, we've been dealing with that for the last 10, 15 years of publishing our own content. And, to be honest, when we were very first getting started, we got a lot of that criticism. I like to think of it as feedback instead of criticism, but a lot of that feedback of, hey, what about this workflow? Or what about that workflow? Or, that's not quite right. No one really does that. But since we've been doing it for so long on the content side, I feel like we've pretty much gotten there. We've invested so much effort into making sure that we know what those workflows are that people do, that there's always going to be people who think that it's not right. And, sometimes they're completely valid. I mean, there are codecs that we're not testing in Premiere Pro that some people are using. Sometimes it's just you can't do absolutely everything. And anything that is a, one-click benchmark is never going to cover all of the bases. The best we can do is try to cover as many of the common ones and then try to pull conclusions out of that. But that's one of the things too with any sort of benchmark is, yes, we give like an overall score on all of our benchmarks. That's one number, but man, that is the tip of the iceberg. If all you do is look at that number and you actually use Premiere Pro or Photoshop, or you actually use one of these applications, it's actually a lot better if you can dive in and be like, oh, I use a codec that's similar to this one or this exact codec, and then only look at that result because everything else is meaningless to you, really.
Yeah.
But even then, if we don't test that one thing, you got to kind of just make some guesses of like, or some educated decisions of this is probably the closest to what I'm doing. And that can be tough. That can be really hard.
Before we're going to go dive deeper into all of the different, Pugetbench from different applications. One of the biggest comments that I've seen on my channel is real world testing. Pugetbench, like you call that real world testing. And then I've had to explain it so many times to people. Do you understand how this, benchmark actually works? So what would you say to people who say, Pugetbench is just another synthetic benchmark that doesn't relate to real world and doesn't taste real workflows?
I would say anything that you're testing, any benchmark, heck, even something that you throw together in Premiere that's like your own project, anything can be considered synthetic in my mind. Because if it's not something you do, it's basically, it doesn't matter for what you're doing. A prime example, I think, is like Cinebench. Cinebench is like one of the most common CPU benchmarks in use out there. Who does it actually matter to? Well, people who actually use Cinema 4D and are rendering in Cinema 4D. And that's really the only people that it is directly applicable to. People use it as an analog for, heavy CPU load, but man, there are very few people who actually are going to be loading all of the cores at the same time. They might think that they are, they might see that, that's rendering. That's the same as rendering out of Premiere Pro. But it's like, no, that's totally different. Yeah. So Cinebench, can be considered synthetic or it can be considered real world depending on what you're doing. And I think it's very similar with our benchmarks. I mean, at least we are testing in Premiere Pro. We're testing in Photoshop. So if Adobe makes a change, or if Adobe has a performance bias towards Intel or AMD, which I mean is true. There are some things that are going to perform better on Intel, some things are going to perform better on AMD. Any of those performance biases are real. It's exactly what you would run into as an end user. So like, cool. That's a real thing. You want to know those. And at the same time, like, yes, we are not testing full projects in Premiere Pro because when you test an entire project, like that would be the best thing you can do. It would be you test your one of your projects with your media, your effects, your After Effects overlays, everything, and you tested that on 2 CPUs, and that's the best thing you can possibly do. You're never going to be able to do that as a part of a single package benchmark. So what we try to do, our way of tackling it, is we try to decode that project into like its base bits. So we have Premiere Pro, we have a processing set of tests. We almost call them decoding, and a lot of times you can think of it as decoding, but it's not a pure decoding test, so we call it processing. That's basically how good is your system at handling these different kinds of source media. And then we have a export test, an encoding test. That's how good is your system at exporting to these kinds of media. And we have a GPU effects test. And so we try to pull it apart into those base aspects and then combine it back together into different types of scores, because usually it's one thing that is holding someone back in their workflow. And so you can look at that one like score or that one specific test and pull it out. So yes, in some ways, I would call it like probably not right, but like a real world synthetic kind of thing where like, yeah, it's not your exact project, but it's as close as we can get it and still have it be a universal benchmark that anyone can run.
I think it just kind of tests a bit more workflows than Geekbench or, Cinebench, like you mentioned that as well, is what you see like usually, CPU tests are like, one CPU is better than the other one. But like how even Premiere Pro and Photoshop use CPU, they use completely different aspects of it. Now with the P cores and E cores, you can use them differently, and it's all completely different. But I do agree with you, and that's what I've seen, and that's why I love Puget. Bench. They actually test in the real application that we're all using, and then you can pick out the ones that kind of fit to your workflow, which is awesome. There is another kind of competitor in there, and a lot of creators are using Apple products. And now when they've moved on to their own silicon, does Pugetbench also work on Apple silicon, and does it work on all of the benchmarks? And what's the future for Apple silicon benchmarks and perhaps even Linux?
I'll start off with the Linux question, I think, because that's the most straightforward. Linux, on some things, we do want to have support. DaVinci Resolve actually is probably the only one that we send out right now that will have Linux support. Purely because Adobe doesn't support Linux. So if you can't install Photoshop on Linux, you're not going to be able to benchmark it. So we're not going to make a benchmark for something that doesn't exist. As far as macOS Silicon, as for macOS Silicon, some of our benchmarks do support it natively. Our Premiere Pro benchmark works just fine. After Effects works just fine. Those are the two main ones that work just fine, no problem. Photoshop was one that we had to do a lot of work on, and that wasn't an Apple thing. That was actually an Adobe thing. And that was because Adobe decided that with the new version of Photoshop, that's the M1 or the Apple Silicon native version, they decided to drop support for their old plugin API. So the way that we were running our benchmarks just doesn't work. And they didn't do that on Premiere Pro. They didn't do that on After Effects. They only did that on Photoshop. And so we had to completely rewrite our benchmark for it. And it took a long time. But that was the main thing that actually drove us to launch our new Pugetbench for Creators app. That's a unified app that has everything. Eventually, we'll have everything in it in one spot. And that was because their new plugin API, it's called a UXP. It's a great API, but it's a lot more locked down in terms of security. So there were a lot of things that we could no longer do with the new plugin API, including gathering system specs. We couldn't just say hey, what CPU is in this system? And it would return it. And that's very important for a benchmark that is out to the public. We need to know, hey, what CPU was this? And so we had to move all of that stuff out to an external application that is now what controls the benchmark, sends the job basically to Photoshop, and then gets the result back. So now we finally have Photoshop support for Apple Silicon. A few of the other ones, DaVinci Resolve is one that we're planning on working on in 2024 to get both Mac OS, including Apple Silicon, and Linux support for that one is one that we want to do. The final one is Lightroom Classic. That one we're going to have to see a little bit.
Why is that the Lightroom Classic benchmark so different on Apple Silicon than what is on Windows, for example?
So it's not actually Apple Silicon. The reason why it's different is it uses a completely different plugin API and language. So all of the other Adobe products are based on JavaScript for the plugins. Lightroom Classic is based on a language called Lua, so very different, and there is very minimal features built into the API for things like benchmarking. Because really at the end of the day, all of these APIs were created for people to add additional functionality on top of the application, and we are doing things that was not really intended in many cases. So for example, in the Lightroom Classic API, you can't import photos through the API because it was like, well, why would you want to do that through an API? You just use the interface. And for users, that's very true. As part of a benchmark, that doesn't really work. And so we have to do a lot of external automation with like macros and keyboard and mouse clicks and things like that. And that works okay on PC. Mac OS, they're a lot more about security, I feel like, in some ways. And so a lot of that stuff just gets blocked, or we can't do it, or we could, but the end user has to like enable a bunch of different stuffs in the security settings. And so that's why like Lightroom Classic in particular is a tough one for us. It's just all of the extra security stuff, and then the way that it's built from the ground up by Adobe.
In terms of the like benchmarks on Apple Silicon and on Windows, you know, at first I think the Pugetbench was through Rosetta or like translating. Is this now through the native version of these applications, and it is like not going any translation, like through any translation anymore?
Yeah, they'll all be on the native. They're not needing Rosetta anymore. Photoshop was the one that still needed to go through Rosetta, which I don't know if I would ever recommend doing that. The performance is nowhere near as good as it should be. So we've never recommended people do that. We just always said, it's not supported.
What about now in the specific applications? If you start diving a little bit deeper into Photoshop, so people who are watching this in certain workflows would start to understand a little bit more what gets tested, how the scores are calculated, and if, you know, they have certain workflow, okay, which one of the scores is most likely to be like linked to their workflow and actually help them with some of the results. So looking at Photoshop first, we have overall score, GPU score, general score, filter score. Let's start with a GPU score, and then we'll get to the overall score last, I guess. How are these individual like lower scores calculated, and what does it mean for people in the workflow, if you can explain that?
So GPU score is one that anytime the GPU is going to matter, we try to build it into our benchmark. It's usually not like a specific thing we're testing, but just like, hey, we pull out like this thing is GPU limited and that thing is GPU limited. And then we combine those together into GPU score. And Photoshop is actually one that we are dropping the GPU score just because it pretty much, you're never going to see a difference between GPUs anymore in Photoshop. You know, in previous versions of our benchmark, you know, when it was intended for, you know, Photoshop, you know, 2020, the hardware was not where it is today. But today, GPUs are just so fast that even like a low-end GPU is almost always going to be CPU bottlenecked on those tests that are GPU accelerated. So that's one that we're actually just like dropping because it's basically pointless. Like it's going to be more CPU limited than GPU limited, even though it is testing GPU accelerated tests. So that one is kind of like you can kind of ignore if you ever see that from like an older version of the benchmark.
I'm glad you said that because I've done some tests with just iGPU and then GPU, and then the like difference has been like maybe this much, and then putting like the absolute best GPU and the difference has been maybe this much. So I've been saying to people, you know, for photo editing, in most of the cases, GPU doesn't matter. So would you agree with that?
Yeah, definitely. We often tell people that getting a discrete GPU is often a good idea, but it's usually for things like video memory than it is for actual raw GPU performance. Because especially if you're getting into really large canvases, tons of layers, having more video memory than what you usually would have easy access to through an iGPU is usually a worthwhile investment. So you're not doing it for the performance, you're doing it for that. On the other hand, though, I will say in like those photo worlds, we're starting to see more people use like stable diffusion locally on their PC for that because they don't want to use like the Adobe AI generative fill now. For whatever reason, oftentimes it's like IP protection, like they can't send anything up to the cloud. Sometimes it's performance, whatever reason. But we are starting to see some people getting way more GPU power than they need for just Photoshop for all of these supplemental workflows.
What about some other softwares that actually, photo editing softwares or photo, developing digital softwares where GPUs get used? Because there's Topaz AI, where people I've heard use as well, that use a ton of GPU. Have you noticed any other like workflows for photo editing that actually require quite a lot of GPU power apart from Photoshop and Lightroom?
No, it's pretty much just going to be those AI things. Stable Diffusion, Topaz AI, like you mentioned. There's a few others out there that are smaller, not as oftenly used. Sometimes some noise reduction software's out there, but I think a lot of people have gotten to the point in like Photoshop and Lightroom that the baked-in tools do more than adequate job. But sometimes you get really bad ones, and then you'll use like Topaz again, Topaz denoise. GPU typically for Photoshop and photography in general, not really as big of a deal. And again, that's one of the reasons why we kind of dropped that GPU score is just it's not telling a useful story anymore. Used to, doesn't anymore. So let's like avoid that confusion.
But I guess that actually puts Intel's GPUs, the Arc A770, in a very interesting spot because of the VRAM of 16 gigabytes, where people can get something very decent for that amount of money from Intel's.
Yeah, absolutely. I mean, this is starting to get beyond benchmarks a little bit more into like our own product line stuff, but we've been looking at the Intel Arc GPUs quite heavily. We're not using them in our workstations yet. Anytime there's a first generation product, we're a little bit more wary. But I mean, we recently did some testing where we did I think it was a 10-month revisit. So we looked at like the launch day drivers and firmware versus what it is now. And it was insane. It was like
insane.
Massive performance increases. But we at least are waiting for the second generation Battle Mage cards, and then that's when we're gonna heavily look into what do we want to do with these. To be honest, we don't do as many budget-based systems. That's not really like our focus, and so like being able to get a couple $100 GPU for us isn't all that critical, just for our user base. But for the general public, awesome. But we're also very interested in using them actually more as an accelerator card than as a straight up GPU for times when you want to have like an AMD Threadripper CPU, but you want all of the benefits of Intel QuickSync. So you can do like HEVC 422 10-bit decoding.
We'll get to that into Premiere Pro benchmark.
We'll get there. We'll move back.
We'll get there. Yeah. Okay, going back to the general score and filter score for Photoshop, could you explain those a little bit?
Probably easier to start with the filter score first. So basically, filter score is everything that's under the filter menu in Photoshop. So, all of the blurs, the camera raw filter, that kind of stuff. We're just kind of lumping that all in one place. That tends to be things that take, a little bit longer to run. You hit go, it's got a progress bar you're kind of waiting for. Cool. So that's all that stuff. General score right now is everything else. It's a little bit hard in Photoshop to divide things up into different workflows, just because you're kind of doing a little bit of everything. So general score is just general tasks, opening raw photos, saving things, doing masking, select subject, all of that just kind of stuff that's typically fairly short operations, but you're doing a lot of them. And so you want to know, for most people, that general score ends up being more important than the filter, because if you're already knowing that you're going to hit go on something and it's going to take 5 seconds, oftentimes you're alt-tabbing to, something else, to do something, and you're coming back and Photoshop has already been done for, 5-10 seconds. So generally that general score is the main score. But then at the end, we combine those just into the overall score. Right now, everything is even weighting, so it's evenly between the general score and the filter score. We've done some experimenting with weighting, less in Photoshop and more in some of the other benchmarks of, hey, for most people, they're concerned more about this than that. Mm-hmm. But you start to get into the situation where like you're telling people what their problems are when everyone has their own unique problem. And so that's kind of like where we take the case of, well, if you care most about that, just look at that score. Forget the overall score. Look at the thing that is actually your headache. So right now, typically, we keep things even when it comes to generating the overall scores.
Even with GPU score. So GPU general and filter will combine the overall score. Is that correct then?
In the case of Photoshop, when we had a GPU score, actually that one was an exception because those tests were already coming in from the other tests. So in Photoshop, when we had a GPU score, that one actually, wasn't being calculated into the overall. In the case of Premiere Pro, which we'll talk about in a little bit, that one it is because it's its own set of tests, its own dedicated looking at GPU effects. And I will note too that with the new Pugetbench for Creators application, we've completely overhauled all of our landing pages for it. And a part of that is what is tested and how are the scores generated and all of that kind of documentation. So if you really want to get into the details of that, you can go on to our Pugetbench pages and really get down to individual tests and what is it doing? What are the settings in Photoshop we're using, down to that level.
So in terms of Photoshop, generally, is that, we understand it's very CPU based and I'm trying to understand how the hardware works for that. And I've done some testing on my own, how much RAM, for example, each of the benchmarks use. And Photoshop is one of those that actually does use more than 32 gigabytes, if I'm not mistaken, on the actual, to run the benchmark. Is Photoshop really single-threaded or multi-threaded mostly? When you're looking at CPU, you see some gigahertz, and then Cinema 4D or Cinebench, single-threaded, multi-threaded tests. Is Photoshop more on the single-threaded side, or does the multi-threaded also matter in Photoshop?
Photoshop mostly, I would consider it a lightly threaded application. It's not single-threaded, but it's also not super well threaded that it's really going to make a difference. Any modern CPU you're going to get is going to have more than enough cores for it. So generally, you don't need to worry about multi-core performance. So generally, if we're guesstimating what a new CPU will be, we haven't seen it. All we've seen is specs. We tend to look at what is the maximum turbo clock, and that is what the single spec that we look at for that. But also, too, architecture can make a big difference in Photoshop and a lot of these other applications, too. Generally, a new CPU architecture will give you about a 10% performance bump just of it, being a new architecture and things like that. That's not always true. 14th gen was
14th gen
was not 10% performance bump, but 12th gen was more like a 15% or something like that. So we're talking averages here. It's not always true. But that's the main things that I would look at if you're looking at Photoshop is single core performance, maximum turbo speed, and just get the latest CPU architecture you can. And generally between Intel and AMD, they tend to be pretty in line right now, at least for lightly threaded applications like Photoshop. So both of them, as long as you're the latest generation, you're probably going to be pretty darn close in terms of performance.
There's also some of the new AI features that have come into Photoshop and Lightroom. Are these accelerated on CPU or GPU, or does it go through cloud, or can you explain how does the hardware handle those AI tasks?
Well, short answer is yes. It's all of the above. Some of them are on GPU, especially the heavier kind of ones, like Select Subject, I believe, is one that uses the GPU a decent amount. Others are CPU based. It just wasn't. My impression is it wasn't worth the effort to make them GPU accelerated. So why worry about it if it's going to be fractions of a second anyway? Cool, who cares? Because a lot of AI stuff is things you wouldn't even think as AI, and it's done so fast that it's not really a big deal. Others, like the new generative fill, is cloud-based, and so that goes up into the cloud. And right now, in terms of Photoshop especially, we're just kind of grouping those all into either like the filter group or the general group. We're not like pulling out AI features specifically. And that's mostly because all of the heavier things, again, generative fill is a great example, they are processed on the cloud. And so like we're not going to benchmark something that's in the cloud because like that your local system doesn't have any real measurable impact on it. As things evolve, as there's more AI features, if they are moved locally, then that's something I could see us adding in as like a specific like AI score at the future. I'm not 100% sold on that, to be honest, simply because who cares if it's AI? Like, really? Like, yeah, it's cool that this is based on AI technology, but if you're talking about benchmarking and testing, is there really a difference between this was based on AI and this was based on just raw code? If they both use the GPU, like from a benchmarking perspective, I'm not 100% sure if it matters.
I can see like now Intel like marketing some of the new things that is coming out. You know, they're talking about the, you know, AI everywhere, or what did they call like everywhere on AI on every PC or something like that. I think they're going to build some AIs into their things. I've seen some AMD is doing similar things, you know. So they were going to have some AI engines on their CPU, as well as, I guess, Apple's neural engine or whatever you want to call it. I know it's not exactly AI, but do you think there's going to be a difference like in those different AI, I don't know, engines, AI CPUs, or parts of CPU that is AI?
Yeah, there will be. And so the reasons why we would add an AI score, one is for the marketing aspects, not our marketing, but for Intel to have something to use to show off the performance of their Art GPUs for AI stuff. It's a big buzzword for reviewers and like, you know, YouTubers of like, hey, look at these AI features. You know, it's something people are interested in. And so being able to pull those out easily would be beneficial. So that is one reason why we might do it. The second reason we might do it is because these AI things are not always an apples to apples comparison between hardware. That's something that the few AI tests that are in Photoshop right now, our Photoshop benchmark, a great example is the resizing. So like you want to make just the image bigger. Some of those things are based on AI. That means you're not always going to get the exact same result from a Intel CPU or an Nvidia GPU or Apple Silicon.
Yeah, how are you going to test it?
Yeah, so it's really, really tough. How we're handling that right now is basically manual spot checks of like we can't check everything, you know, every single run, but we can compare an M1 laptop result to a PC result, get down to the pixel peeping, you know, level, and like make sure like, oh, did it do as good of a job? Sometimes those things are just kind of judgment calls because like it is different, but is one better than the other? It's really tough.
That's a really good point.
Yeah, so if we end up in some situations where it is not a apples to apples comparison, then we are going to have to do something about, you know, pulling it out and calling it out separately. Most likely, the way we would do it is it would be a completely separate benchmark preset. So a lot of our benchmarks right now, we have like a standard preset, an extended preset. We might have to have an AI preset, and it would just test those things, and we would just have to be very clear about saying that, hey, we're testing these things, but you have to be careful in how you use this. It's not always an apples to apples comparison. You know, only use it when comparing a PC to a PC, when comparing an Apple unit to an Apple unit, and that kind of thing. I don't think we're at that point right now. Everything I've seen, it is close enough to an apples to apples that it's okay. But, you know, who knows in the future?
I think we can move on to Lightroom Classic now. I said Lightroom Classic, but there's also Lightroom and Lightroom Classic. And the benchmark is actually for Lightroom Classic. Could you explain that kind of relationship there? Like, why Classic and not the normal one? And why is there a Classic and not Classic one?
Oh boy, the reason why there's a Classic is, that goes back. I remember when they launched Lightroom Classic, there was a lot of not very happy photographers because they launched this new version, and like as great as the new version was, like everyone considered that like the newfangled thing, not like, so why did you rename it? It's like calling Coca-Cola Classic and things like that. I don't know. There's a lot of opinions there. But the reason why we test Classic is twofold. One, it tends to be that the power users, the people who care about performance the most, tend to use Lightroom Classic. It's got a little bit more of the heavy kind of effects and processing, things that take a little bit longer to run. So that's one of the reasons why we focus on it. 2 is Lightroom Classic is primarily local based. So all your photos are on your local PC and you're working on everything locally. The Lightroom, not Classic, is primarily cloud-based. So your photos are in the cloud, you're processing stuff, it's saving things up into the cloud. And so like whenever you're having cloud as a part of it, it makes it a lot more difficult to have repeatable results, because like if your internet slows down, if there's Adobe servers are a little bit more loaded, it can cause, variances in the results. So those 2 main reasons are why we typically are focusing on Lightroom Classic. Could totally change. Lightroom Classic, to be honest, is due for a major overhaul, like our benchmark, because they've added a lot of new stuff. There's a lot of new AI features that we're not testing right now. So it's due for an overhaul anyway. And when we do that, we'll probably also take a look at Lightroom and see like, hey, is there either some way we can make some unified thing that can test both? Or, is it something we can port over? As far as I understand, though, the backends are completely different. So there's not going to be a very easy way to get double our return on our work. So probably we'll continue focusing on the classic version, again, just because that's primarily where we hear people talking about wanting more performance or like upgrading their systems to get better, better export times or better processing times. Almost always it's with Lightroom Classic.
Makes total sense. So now Lightroom Classic has only like 2 subscores and 1 overall score. So we have the passive and active scores. And could you explain what are these scores and how does the hardware utilize or work with these scores? Like whether it's Apple or, AMD or Intel, how do these scores work?
Passive score is anything where you click a button and then you have to wait. So importing photos, you could be, for some people it's very fast, but there's a lot of like wedding photographers. They're going to have 2,000 photos. So they start importing that, they hit go, and it's got a progress bar. And usually like you can start working, but usually they wait until it's done. Same thing with like exporting. You have a whole bunch of stuff. You've done a whole bunch of edits. You've got 200 photos you're exporting for this wedding. You're going to hit export and you're going to wait for that progress bar to go across. Those are the kind of things that we're calling passive tasks right now. And I will admit, these are not the best terms or the best we can come up with. So if anyone has any suggestions on like different ways of wording these things, again, we're looking at doing a revamp later in 2024. So let me know. But that's what the passive scores are right now. Active is anything where you are doing it and usually like the computer is kind of waiting on you. Like you're sliding things, you're switching between modules, you're scrolling through images. Usually the computer is fast enough to keep up with you. Not always, and like the faster it can be, the faster you'll be able to be. But usually, like you're doing something and you're waiting for it to complete, and many times a second. So it's not big long things that's taking 10 seconds to a minute. It's sub-second kind of things. And so that's kind of how we're dividing up our tests right now. Because usually, again, from our own interactions with photographers, both through the sales side, for our workstations and going to Adobe Max and shows and things like that, tends to be how people kind of divide up their bottlenecks. It's either I'm trying to scroll through things and I want to scroll faster, or I want to switch around and like do things faster, or I have to export 1,000 photos and it's taking forever. It's usually one of those 2 things. So by dividing up the tests in that way, people can look at, well, these are the kind of things I'm doing, or this is the kind of things I'm doing that is the bottleneck to my workflow.
So in terms of the hardware now, multi-core performance, single-core performance, which like uses which on which? Like, is there any, it's quite obvious that, it should be like single core when it's active, when you're working on it. It's going to be like boosting the cores and like the fast cores that are doing the work. But then the passive score where you're exporting or putting a panorama together or something like that, does it use single core performance there as well? Or does it load just the whole CPU cores equally, pushes that? Or can you explain what's like your experience testing the hardware and seeing the single core, multi-core threaded performance and those cores.
Yeah, so the active tasks, you are exactly right. The active tasks, you're doing small little operations that tends to be very lightly threaded, very similar to like Photoshop. So yeah, single core, sometimes 2 or 3 cores, and that's pretty much it. The passive score, you're doing longer jobs, and so Lightroom will oftentimes divide things up. So like, well, why export 1 photo at a time when you can do 5 in parallel and like divide those up across multiple cores? So it is a little bit more multi-threaded. It is not anything like super crazy heavy. Usually there's no benefit to going to something like AMD Threadripper Pro with 64 cores. Usually still going to be slower than like a 12 core Ryzen. So like there's a limit, but it is a little bit more threaded. We're also starting to see more GPU coming into play on some of those things. Like I know some of the exporting now is starting to use GPU acceleration, kind of similar to Photoshop. Like it makes it faster. It is definitely very beneficial, but oftentimes the bottleneck is still on the CPU side. Like it's great that it's twice as fast. Like it can be significantly faster. So it is a good thing that there is GPU acceleration. I want to be clear on that. But bigger GPU is not always going to give you a bigger performance jump on top of that, simply because it's so fast already that it's still waiting on the CPU to write the file to disk, or things like that that are always going to be CPU.
I'm just curious about now the architectural difference as well. Like the new hybrid architecture with Intel, we can see a benefit in some of the video editing, especially in Premiere Pro. I've seen like they really utilize this well, and I think like Intel made it for creators, not like gamers, because I don't think gamers are going to get very little benefit for the hybrid cores. But in Lightroom Classic, is it actually kind of trying to use one over the other? Or is it just going to use it equally? I can see that the active task, obviously, performance cores, but in the exporting and passive tests, what do you see there? Like if you've got the i9 14900K, for example, you've got quite a lot of E cores there. Is it going to load the P cores first and then E cores, or E cores first and then P cores, just to give you like the flexibility of still using the system? Have you seen anything in there? Just curious about the hardware.
Yeah, that's starting to get into pretty complex stuff, actually, because that oftentimes is actually dictated by Windows. And so it depends on kind of what you're doing. If you just have Lightroom up and you're exporting, it should use all of those performance cores, and it'll just use those. So like when we're doing benchmarking, that tends to be what is happening. Now, if you're exporting something and it's going to take an hour, well, usually you're probably going to minimize that and go start doing other stuff. And Windows, how it's supposed to work is anything you are like actively doing, it tries to do that on those performance cores. And anything that's like kind of going on in the background, it might shove off to the E cores if there's not any performance cores, available. And so it could be where it gets shoved off onto those E cores, and it could be a little bit slower. That is incredibly difficult to benchmark in a repeatable manner. I would almost say it's impossible. Like if you really wanted to do that, you would have to do 20, 30 runs, highly automated, so that and then like take an average between them. Like it would be really difficult. So typically though, for most people, I would say the P cores are really what are being used the most, because Lightroom is not well threaded enough that it's going to spill over past those P cores. That's one of the reasons why like the 13900K with I think is it 24 total cores, something like that, like 8 and 16
plus 8.
Yeah, so that is still on par with like a Ryzen 7950X that has just 16 full performance cores, because even like the 7950X, you're not using all 16. You're probably going to be using, I don't know, five or six. Like it's really hard to say exactly how many cores are being used, because you can't just watch Task Manager, because it's going to jump around like all the time. Yeah. Like it's really difficult to tell how many cores you're really using.
So have you seen like a cap of, or has Adobe said something secretive? You know what, we've only done it for 8 cores, and anything above that is actually like our program can't just utilize that? Or have you just seen a sweet spot where this is like, okay, 8 P cores? Because 8 P cores has been the standard until Ryzen got it to 12 and 16.
I think usually it's a sweet spot thing. I don't think very often there's too many applications where they hard code like this is going to use 4 cores and that's it. Like, because that's not very scalable. There's going to be some old code that might be that way. There might be some old code in Lightroom or Photoshop that is that way. I don't think that's the norm. Usually, I would say today, your point of diminishing returns in Lightroom Classic and Photoshop is going to be around 4 to 8 cores. Now, that is just for the application. I mean, you still have Windows. You have Spotify running on Chrome. That's going to use up a little bit of CPU. So you have lots of other stuff. So we're talking just the core application, probably somewhere between 4 and 8 cores. That's one of the reasons why like the 13700K is often within 1% or 2% of the 13900K in some of these applications. It's just you're not really getting much of a benefit of those additional cores. And like single-threaded performance is like identical between those CPUs. So you really don't see much of a benefit, but you do see a benefit from like a 13600K up to a 137. So yeah, it's usually going to be somewhere around there. Usually like the i7 or the Ryzen 7 line is usually like a sweet spot in terms of core count.
And I've seen some photographers like commenting and like engaging on my channel who have chosen to use Threadrippers for Lightroom because they do like batch exporting or batch converting photos to different formats. Have you experienced that as well? And now I know they're using, I think, Threadripper 3000 series. Now there's the 7000 coming out. But do you think there is any, I know you said that there isn't really, but do you think there is any benefit for Threadripper in very specific workflows for photo editing?
Specific workflows, yes. Just straight up like Lightroom or Photoshop, no. Usually you're taking about I'd have to go back and look at our actual benchmarks. I think it's anywhere from 10 to 20% performance hit by using Threadripper versus Ryzen or Intel Core. So more expensive, 10 to 20% slower. Why would you do that? Now, there are additional workflows outside of like Lightroom Classic where you can get a benefit. One of the big ones I know of is actually astronomy. You know, they take tons of photos of the night sky and then they stack those. You can do that in Lightroom and in Photoshop, but I think a lot of times they use like external separate applications, and that kind of stuff can be very well threaded. Some of those batch conversions or exporting, if you're using a separate utility that can split that up into more jobs, cool. I mean, in those kind of cases, more cores is more better. You're kind of getting into the situation where Cinebench might actually be a better benchmark for that workflow than our Lightroom Classic benchmark, because of just the nature of how you're dividing things up. You can, in theory, get perfect scaling similar to something like CPU rendering with Cinebench. So yeah, those kind of workflows, there are ones. It's not very common. It's uncommon enough that like with our workstations, we don't even really advertise Threadripper at all for Photoshop or Lightroom, because the one time a month it comes up, usually they know that they're a little bit unique. And, you know, that's the role of our consultants, is to talk to people and be like, oh, you're doing something a little bit different. Cool, go over here. But for the 99%, no, usually it's not worth the investment.
Moving on to video editing, but before we go to Premiere Pro actual application, I think we need to talk about video codecs, because there's been a little bit of a change in Premiere Pro benchmark, I've noticed. And, live playback's gone. And now we have something called LongGOP, Intraframe, and RAW test. Now, these are different types of codecs, right? But I think I'd love to hear your explanation to the audience about the different video codecs, because their cameras, they don't say that it's recording LongGOP or Intraframe. They see something like H.264, H.265, RAW. Okay, RAW is a little bit easier to spot, but it might be ProRes RAW, it might be Canon RAW, Red RAW, Blackmagic RAW. They all are a little bit different on the hardware as well. Plus, when they actually look at the file, their H.264 codec is actually .mp4, .mov or something like that. So this can be very, very confusing understanding, wait a second, which codec am I using and which benchmark results should I be looking at? Can you explain that whole world of video codecs And like, how does that work?
Yeah, it's a difficult world, and honestly one that there is a lot of confusion. Like, I think if you actually go in and you can spare the couple of hours to study up on it, it's fairly straightforward. But there is a lot of, I guess you'd call it misinformation. It's just wrong information. People have a preconceived this is what it is, but it's not quite right. A great example of that is like if you're ever on like the video editing subreddit, one of the most common questions is, well, what codec are you working with? And the most common answer is it's MP4. Problem is that's not a codec. That's a container. That's a wrapper. So that actually could be anything. Like or MOV is the even better one. MOV could be H264. It could be HEVC. It could be ProRes. It could be like anything. And so, yeah, that whole division between what is a codec and what is a container or a wrapper, that's a whole big source of confusion out there on the internet. Same thing with like even within H264. Well, it might be H264, but this camera calls it XAVC or whatever. Like they have all these different terms for things. So our attempts to at least make our benchmark be, if not clear to everybody, but accurate, was to divide our testing into the different types of codec that use hardware differently. So Intraframe is probably the most clear as far as like how hardware is used. So Intraframe, the definition of it is every single frame is a picture. It is all it is. It's just a series of pictures. ProRes is the most common one. DNX HR or DNX HD is the other one. It's primarily going to be one of those two. And it is CPU based, entirely CPU based right now. I know there's some efforts into making it GPU accelerated, but it's just CPU based, very light codecs as far as processing, very large codecs on your computer, like on your storage, because every single frame is an entire picture. But like, in terms of best workflow, that is ideally what you'd be working with, because it is just so easy to work with. That's why like Avid Media Composer, they basically not force, like you can do native editing now, but you're supposed to convert everything into DNX before you start editing, because that's the professional workflow. So that's intraframe codecs. And then you have things like, we use LongGOP for H264, HEVC, if we ever include like, AV1 or VP9, those would fall in there. And we use LongGOP, but there are two words that you could use. You could either use LongGOP, long group of pictures, or you can use interframe. To be honest, interframe might be the better term to use, except people would see interframe and then intraframe. And honestly, I get confused about which one is which, because it's inter versus intra, and you got to think, you got to Google it. So we decided to use LongGOP. And the difference with those codecs is you have a first frame that is the entire frame, entire picture, but then all of the frames after that are just what has changed. So like with my video, the background's not changing at all, so that it wouldn't re-record the background. It'd only record what I am doing. Now, that means you can have very small file sizes, but it's really hard to process. Very, very difficult to process. That's one of the reasons why that's the most common question is what codec you're working with, because someone will say it's H264, and then everyone says, that's terrible, don't do that. But it's the most common codec people end up with anyway. So, really hard to process, and it can sometimes take advantage of hardware acceleration, hardware decoding, hardware encoding. This is where you get like Intel QuickSync comes into play. You get GPU-based decoding, which Premiere Pro got 2 years ago, I think, or something like that. So like these specialty decoders can make a bigger difference than like your raw CPU power. So that's why we pull those out. And then, like you mentioned, we have the raw codecs. Raw codecs like Red, Sony XOCN, Cinema Raw Light, ProRes Raw you mentioned. Blackmagic Raw.
Blackmagic, Arri.
Yeah, all of those. And those ones are a bit of a grab bag as far as like how they use hardware. Red uses GPU very heavily, but also CPU pretty heavily as well. Somewhat multi-threaded, but yeah, strong on GPU. Arri Raw in Premiere Pro, I think they just recently got GPU acceleration. Before that, it was man, throw as many cores and as powerful cores as you can. Now it has GPU acceleration, so like you can offload some of that onto GPUs. Blackmagic Raw is very GPU heavy, not as heavy on CPU. So Raw is one of those where like it's a lot tougher to really say like one as far as like this CPU or is best or that GPU is best. But generally they're going to be heavier both on CPU and GPU. And as far as whether it can use multi GPUs, it will depend on the application. Like Premiere Pro doesn't. Resolve does sometimes, not always. Like it can for Red, but not really for like Blackmagic Raw. So it's a lot more difficult as far as like what hardware is best. And so we divide up all of our testing into those three codecs, or those three types of codecs, because of how differently they utilize the hardware on your system. Because when we ask our own customers, we have a customer coming to us who wants a workstation, the very first question we ask is, what codec are you working with? Because that will decide whether we should have them on Intel Core so they can have QuickSync support, or should they be on AMD Threadripper with like a RTX 4090 GPU because they're doing RAW, or if it's Intraframe, it's like, all right, we don't have to worry about that. What else is in your workflow that is probably going to be a bigger bottleneck, because Intraframe is going to be no problem on any system we sell.
Just a quick question here, because I think this might be very camera specific, but for example, Sony cameras, a lot of the people who use them, they see one codec that's called, let me just not miss it, XAVS-I. Now, is that I interframe or intraframe?
So XAVC would be, it's either H64 or HEVC. I'd have to Google exactly. But it's one of those two. The -I usually means that it is an all-I codec. So, I was talking about how like H64, you have the first frame is the entire picture, and then everything after that is only what is changed. Those are called, I think it's P and B frames, like different types of those kind of things. The first frame that has everything is called an I frame. So if it's all I, basically what you're doing is just saying like, forget the whole LongGOP thing. We're just going to record as if it was an intraframe codec, and every single frame is everything. It is recording absolutely everything. The benefit of that is oftentimes it's easier for you to process, because like the system isn't having to say like, okay, hey, you want to look at frame 10? Cool. I have to go back and look at frame 9 and frame 8 and 7 and 6 all the way back to frame 1. It can just say like, oh, frame 10, cool. It's frame 10. So it's easier to process. Generally, though, you don't get as good of quality for the bit rate, because you're not getting the benefits of the compression of like, only recording the things that change. Since you have to record everything every time, you're starting to get into the realm of like ProRes type file sizes for the amount of quality you need. So it's a trade-off. It's easier to process. Should be a little bit lower quality. It's not always. Sometimes you get better quality if you have like really fine details in the background, like trees or grass. Sometimes that compression does weird stuff, so it's better just record all I, and so like every single frame is the entire picture. So that's what the I usually means.
For all the Sony users, just you can see this very easily now, how the Intraframe and LongGOP difference is that your XAVCS, when you have an I in the end, you can see that bitrate is actually recorded much higher than your without I. So there's more compression when there is no I. It's harder to look through. All I, the bitrate is higher. You've got more frames there, and then there's that difference there. And the less the codec is compressed, the easier it is to play back on most of the cases, apart from RAW. Is that the same RAW as well?
Kind of, sort of. RAW, like you have like Red RAW where you can have different compression levels. Yeah. Sometimes you get unusual results than you would expect, just because like, okay, you have these giant file sizes and you're reading the entire frame. Is it faster to read a giant file that's less compressed, or is it faster to read a smaller file and then do that decompression? It's not as straightforward, unfortunately, as you would think in that situation.
We've covered pretty much everything now on Premiere Pro already, what you've said here on the difference there. But one of the main things people see is extended and standard benchmark. Now, because you can see the same scores, like you see the LongGOP, Intraframe, RAW, and GPU effects on standard and on extended. Could you explain the difference between standard and extended? Like, why would one want to test only standard or with extended as well?
Sure. It's basically extended is everything. It's everything. All the codecs we're looking at, all the GPU accelerated effects. It's absolutely everything. Standard is the more common ones for most users. So something like 8K HEVC. Not very many people are doing that. So it's in the extended, but it's not really in the standard. The same thing with like 5K Sony XOCN. How many users are there really that are using XOCN compared to all of Premiere Pro users? It's a small fraction. So that's why, like, hey, if you're just doing for a general tech audience, not really even for video editors in particular, then just running the standard is probably fine. The second reason we have a separate preset is sometimes lower end systems, laptops, those kind of systems just can't handle those. If you don't have a mobile GPU with enough video memory, well, you're not going to really be testing 8K red. It won't work. And so that is the other reason why, like, we have that smaller preset. The standard preset is for, you want to check mobile devices. You want to check lower end, like Core i3 and lower Celerons or Pentiums, that kind of stuff. You're not going to be able to run the extended at all. And so that's our way of letting people run this, the benchmark still, even when they don't have, really the hardware for it. And so that's one of the reasons why when you run the extended preset, it still gives you a standard score, because it's still just a subset. And so you can, if you can run extended on some systems, but not on all, at least you have something that you can compare to, and you don't have to double run benchmarking, on those higher end systems. It's just, what is the system capable of? I think with our new benchmark version that we're just putting out, I think less people are going to do the standard just because the time to completion is a lot faster on the new version. So there's less of a, I could run the extended, but it'd take 40 minutes. The standard will only take 20. Now it's like, it's the difference between 10 minutes and 7 minutes. Whatever. I might as well get the extra data and just run the extended.
We have now the GPU effects as well, which we'll talk about, but mostly the standard, is that using lower resolution of video codecs or video files as well as the extended? So extended is 4K plus as well.
Relatively lower resolutions. The lowest we go is actually 4K. We don't go all the way down to like 1080p, even though a lot of people are still working in HD. We start at 4K, but like the 8K tests are going to be reserved for the extended. The really heavy raw stuff is going to be reserved for the extended. Resolution comes into play a little bit. Resolution oftentimes doesn't actually matter as much as you would expect when you're doing relative performance between two CPUs. You have an Intel CPU and you have an AMD. If you're doing some 1080p tests and some 4K tests, usually like the percent difference between those two isn't going to be too far off. It does come more into play when you're talking especially like raw, and HEVC 8K comes into play more from like what is available from a hardware decoding standpoint, and those kind of things. So it's not as much, again, the resolution as it is what does it require for the system to be able to do it at that resolution.
If you take let's say a very simple, a 10-minute clip on Premiere Pro that is H.265 from your Sony camera, let's LongGOP, for example, but you've got that converted down to, I'm making it a bit more complicated. Let's say somehow you've got 1080p and 4K, same clips, bitrate can't be the same, but exporting that, you'd say that 1080p and the resolution difference isn't as big as the codec difference, if there was any.
Usually codec makes a bigger difference, but I do want to be clear that I'm talking about relative performance. Like the 1080p clip is absolutely going to export faster. But if you're comparing export times between two products and you're converting it like into percent, like this CPU is 5% faster than that one, usually it's going to be pretty similar between whether you're doing 1080p or 4K. So when we're talking benchmarks and converting everything into a score, it's better off from a benchmarking perspective to do something that's more difficult, so that we're doing an export that's taking 10 seconds to complete rather than an export that takes 1 second to complete. Just because the shorter things are when you're doing a benchmark, you can introduce more variance, more margin of error. And it's not always the same. Like our Premiere Pro benchmark, our goal was to get it to be able to complete as quickly as possible while not having that larger margin of error growth. So we experimented with everything from, we're going to have the exports take 10 minutes each, down to we're going to have the exports take 1 second to each. And we try to find that sweet spot of where do we start getting run-to-run variations, and then plan for at least twice the performance for future hardware. And then cool. Okay, so we'll double that, and then that's where we're safe at.
Now the GPU effects standard and extended, how is that working on Premiere Pro?
So GPU effects in Premiere Pro, to be honest, are not as important as something like DaVinci Resolve. So we don't focus on them nearly as much as we do in DaVinci Resolve. We have some things that we're testing because it's more important to have a good GPU than it is in Photoshop or Lightroom. But most of the time, that is for things like you're working with raw footage, not the actual GPU effects. Like Lumetri color is like minuscule GPU load. So that is one of the ones that, the people who kind of say like this is kind of synthetic, that's probably the closest thing to a synthetic benchmark that we have, or synthetic test, I should say, as a part of our benchmark. So we are doing some things like we're going to have to load up the Lumetri color 30 times. And in fact, actually, let me just double check here. I want to make sure that I'm not saying something wrong, because again, we just tweaked all of our tests. Yeah, okay, cool. So for example, Lumetri color is super easy on your GPU to do. And so if we just tested one instance of Lumetri color, you wouldn't see anything. It's still going to be CPU bound, or your codec is going to make way more difference than anything else. So what we have to do is we have to take Lumetri color and apply it 40 times on the test. Ooh. Completely unrealistic. To be honest, completely unrealistic. You're never going to do that. But that is the best way we found to show the maximum performance difference between multiple GPUs. Now, if you just look at that one test, I don't know how useful it really would be. Like if like Lumetri is the only GPU effects test you use, don't use that GPU score to determine what GPU you want. But when you combine it with all of the others, the Gaussian blur and the sharpen and like the denoise stuff, then you start to get a better idea of what is the maximum performance gain you could possibly see in Premiere Pro if you upgrade the GPU. So usually what we tell people is, hey, if you're looking at a GPU upgrade, look at the GPU score, look at the overall score, and know that that GPU upgrade is going to get you somewhere in between those two. And where you are depends entirely on what you do. If you just do Lumetri and like maybe a sharpen, it's going to be closer to that overall score. If you do a bunch of like denoise and like you use a ton of effects, you might be closer to that GPU score. And so it's one of those ones where you kind of have to understand what it's doing and kind of pull out what that means to you, which admittedly is difficult, but that's kind of the reality when you get into these real world workflows and like you want to have a single benchmark that you can run rather than testing your own project on multiple pieces of hardware.
The reason I'm asking about the GPU is I'm not sure if you guys have done a test with the 79XTX from AMD or Radeon, and then the 4090 recently. I tested it with the Premiere Pro 23.6, so it's not the latest 24, and Pugetbench 0.98. And the interesting bit, what I found, is that all of the raw, LongGOP and Intraframe is actually better on AMD with their media engines. And I was like, this wasn't the case like before, like 1 year ago. They've done some great improvements with the drivers. Looking at the raw and the GPU effects, Nvidia is like miles ahead as AMD, which makes me think, is there also a difference in the encoding, decoding quality of the GPUs? Because I know Puget Systems doesn't use a lot of AMD cards, if I'm not mistaken. Could you explain why is that? And is that true that one can be better than the other?
Yeah, it very much, I think you pretty much hit the nail on the head. AMD GPUs for quite a while now actually have been better for processing like H.264 and HEVC. Our benchmarks, our previous versions of the benchmarks didn't show that as well because we weren't testing very many flavors of H.264 and HEVC. Because like you say H.264, but there's multiple things that go into that. You have the bit depth, 8-bit, 10-bit, 12-bit. You have the chroma subsampling, 420, 422, 444. Those two things are primarily what decides what kind of hardware decoding the hardware has to support. AMD GPUs support some, Nvidia's GPU supports some, Intel QuickSync supports a lot more. So like the iGPU on Intel's or Art cards. And for the codecs that we are now testing, which we feel are, I hate to throw a number here, but maybe 75% of the most common codecs, just because there's so many variations. AMD does have a lead there. They're not as fast as QuickSync, so Intel iGPU. So like you asked, like our own systems, we don't use as much AMD partially because we want to keep our product line as slim as possible. It's not taking it to like the Apple extent of slim product line, but there's a lot of things that it lets us do when we have a slimmer product line. And when we are having a customer that is concerned about those kind of codecs, we almost always are putting them on like an Intel 13th gen or an Intel 14th gen where they have QuickSync, which is going to be better than what AMD can do. So it doesn't really matter as much. But yeah, if you're building your own system and you don't want to go Intel, you want to use AMD Ryzen because you're a gamer and like you want to use an X3D CPU or something. But you work with these codecs, then an AMD GPU, I would say, is, definitely a terrific choice. And that's also kind of brings up one of the other difficulties with like this kind of benchmark is we have that GPU score, but we very specifically call it a GPU effects score. It's not intended to say like this is just the GPU. This is the only things that the GPU is using. Because like you mentioned, the LongGOP score can be very different. The raw score is probably going to be very different, and NVIDIA is probably going to be better on the raw score. So that's kind of one of those situations where, like, man, almost everything in Premiere Pro is affected by the GPU except for Intraframe, that one score. So at least the overall score will kind of tell you kind of a story, but you definitely do get into some situations where, like you mentioned, AMD is better for LongGOP, NVIDIA is better for GPU effects. And so they end up just like equalizing in terms of the overall score. So overall score is great when you need a single number. Like you're a tech reviewer who's just for general tech. Cool, use that. But if you want to get into the nuances, there is a lot that you can dig into. Once you understand kind of like what it's doing and what it's telling you.
So let's dive a little bit more deeper in there. Is one media engine what they have on the GPU? Is one better quality than the other when it actually, decodes, encodes? Probably encoding is more where you see the difference. Is there a difference there? Because both of them now, advertise AV1 and dual media engines, which AMD actually doesn't say that, like in any of the, keynotes and any of the specs. I had to like dive deeper into to actually see there is two media engines, and you can see that on Task Manager, for example, as well as Nvidia, like some of the top end cards. Is there a difference between these media engines, what you have seen, like in terms of the encoding quality, stability? Because Nvidia also offers the studio drivers.
Yeah, so there's many questions in there. So if I miss one, please bring it up again at the end there. So starting with the quality, it's like you're looking at my backlog of like what I need to do. Because that's one of the things on my backlog is to do a straight up quality comparison, because it is not the same. Now the question is it enough of a difference to matter? And if it is enough of a difference to matter, at what bit rate does it actually equalize? Because you could always get better quality just by upping the bit rate. So if GPU brand 1, because I don't know which one is better. So GPU brand 1 needs to encode at 100 megabit, whereas GPU brand 2 only needs to encode at 80 megabit to get the same quality. That's really good information to know. And to be honest, that potentially could introduce some changes in our benchmark even. Like, if I really don't want to do this, but it's possible we would have to say, like, if AMD GPU encode at this bit rate, if NVIDIA GPU encode at this bit rate, because in the end, what is most important is that the final product is, what someone would be using. If you're going to upload to YouTube, like, if you have to update up the bit rate, that's a really real thing. I hesitate to do that because AMD launches a new GPU. Now it's different. Cool. So I really hope we don't have to do that. But that is definitely something that is on my to-do list to look into. It's really tough. We've done some spot checks in the past, and it's different. Which one's better? Oh man, it's really hard. There are utilities out there. I think like Netflix uses them, some other people, where like you can compare the source to the encoded video and it gives you like a quality score. I would never trust just one of those, but like, heck, if it's what Netflix uses, it's probably good to use. So I do want to do that kind of stuff and find out really if there is a difference. I can tell you, yes, there is a difference. My impression is that Intel is one of the better ones, Nvidia second, and AMD third. The question is by how much? Like if it's a 1-2%, who cares? But that's kind of my general impression, but I need to back that up with testing before like I say it in a form of like written content. I guess it's quotable, but whatever.
Let's do the stability then. Drivers and, different AMD, Nvidia, we've got studio drivers. Do they actually give any difference, what you've noticed? Because what people need to understand is you've got all of this data from all of the, hundreds, thousands, maybe tens, hundreds of thousands, maybe customers who've used this, and you've seen like what people work and, how does it work and when it works, when it doesn't work. So the drivers, GPU drivers, let's talk about that.
So the easiest one that I don't think there's going to be any pushback on is the studio drivers versus GeForce drivers or game ready drivers. Definitely use the studio drivers. They get not to the same level of testing by NVIDIA as like the Quadro or the RTX Pro now. The RTX Pro drivers, like they don't get quite as much like validation and everything in these media apps, but they get some. And that is enough to, have most of the issues that come out of those game-ready drivers taken care of. Because those game-ready drivers, like they will publish a driver update every couple of days, every week. Like they're constantly churning things out. There's no way they're testing it in Premiere Pro and all this other stuff. Like it is intended for gamers. And even then, I would only ever use the latest game-ready driver if it specifically says in the update notes that it addresses a game you actually play. If it doesn't, there's no point. Because one of the other things that I think a lot of people don't realize is all of those game optimizations that are in the game-ready drivers do make their way to the studio drivers. The studio drivers still get those. It just only gets them every month, every 3 weeks. Because they're doing all this stuff on the game-ready side. They push it over, and then they have to do all the certifications, and then the studio drivers launch. So you're still getting that benefit. It's not like, hey, I'm a gamer too, so I have to use the game-ready drivers. Like, no, it's fine. The studio drivers, they'll do everything unless there's a specific update that addresses the game you are playing. The studio drivers, number one thing with like if you have an NVIDIA card, that will give you better stability in any of these kind of content creation applications. So absolutely only use the studio drivers if you at all can. AMD versus NVIDIA, that's a tougher one. I think I can be pretty safe in saying that NVIDIA drivers are more stable if you're using the studio drivers than AMD drivers. AMD has gotten quite a bit of feedback over the last several years or so of like how their drivers do have a little bit more issues than NVIDIA. I will say, though, that AMD has made a lot of strides recently. Like they are really focusing on this kind of stuff. We're seeing it in like the AI world a lot, where like they're really competing with like NVIDIA with their CUDA architecture and everything. they're doing a lot. So if you have an AMD GPU, I don't think like it's a terrible thing or anything at all like that. I would maybe caution a little bit against updating your drivers if there's not a problem you're having. If you have an AMD GPU, I think it's a little bit safer with NVIDIA and the studio drivers. But, you know, I'm hopeful that in like the next year or so, AMD is going to have their stuff all polished up and ride in line with NVIDIA.
There is now some AI features in Premiere Pro as well, but I guess the answer is about the same, that it uses some GPU, some CPU, depending on what, and the answer is pretty much similar to all of the other applications. Would you agree with that?
Yeah, it's going to use a little bit more GPU, is my impression, than like Photoshop AI stuff. A little bit heavier. Those things are some kind of things that we would like to test a little bit more in depth. I think one of the reasons why you might not see very much is it uses a lot of caching. It's one of the reasons we don't have an article on like scene edit detection or the audio transcription. Is you'll run it once and you might get, it took 5 minutes. You run it again, it took 30 seconds. And like, no matter how much clearing of all the official cache files we do, we can't seem to find where those cache files are. And so it makes it really difficult to do some sort of testing, because it really doesn't matter how fast something is when you run it multiple times, because how many times are you going to do a scene edit detection twice? Like, never. You're going to do it once and then it's going to be done. So it's that first run that really makes a difference. So we're still working out how can we test those kind of things in a repeatable manner and get a result that actually is applicable to end users. Once we figure that out, I would love to have, you know, some sort of AI, you know, test those things. Because some of them I feel like gimmicky probably isn't the right word, but not very many people are going to use. Like the scene edit detection probably is a great one. Like, yeah, it's useful sometimes, but like no one's really going to be like buying a new system to make it a little bit faster. Audio transcription though, yeah, with all the text-based editing stuff that they're doing now, like if you can make that faster, yeah, I can see someone investing in a CPU upgrade. So we do want to test that stuff when we can, but there's a lot more that goes into that than just, hey, let's just hit go and time it, unfortunately, when you're dealing with caching.
In terms of Premiere Pro now, when we're talking about, let's take RAM and GPU out of it. You've mentioned GPU. CPU, single multi-threaded, where does that kind of slot in there?
I'd say most of the time it's going to be moderately threaded. Not to the point where you need more than a Ryzen or an Intel core. I think most of those CPUs are going to be more than enough for most people. Exception being if you're working with RAW, then you can get up into, that's where like Threadripper Pro can give you a performance advantage, especially if it's higher in like 8K Red, RA RAW. That's where you're getting more heavily threaded. Even there though, there's a diminishing returns. Like we never go beyond 32 cores on the Threadripper Pros for Premiere Pro, simply because usually you're not getting a performance increase. And actually it can be a decrease just because of the way that Windows works when you get above 32 cores. It does some funny business. And so we almost never will go beyond 32 cores, even with those raw workflows.
I think we've nailed Premiere Pro. We've got 2 more video editing applications to go, After Effects and DaVinci Resolve. So going to After Effects now, there is a few things. I know not too long ago you changed the benchmark to actually test the multi-core as well, because After Effects introduced a way to actually use more than a few cores, and bigger CPUs actually made a difference. So could you explain the scores, and then the overall score?
The multi-core score is the one that you're kind of referring to, the multi-frame rendering. That is actually something that is not calculated in the overall score. It's something we pull out separately. So it is just from that one test that it's like a stress test for that feature. It's actually the same composition that Adobe used to advertise multi-frame rendering. We actually know the person who made that, and we work with Adobe. So we took that, we trimmed it down a little bit. We removed like the special fonts and things like that. They don't really affect anything. But so like that is a great stress test of like how much of a CPU can you get and still see a benefit. So like it is like, if you want to know, like, should I get Threadripper or not? That's kind of what that is. And then we have we do have a GPU
so
score.
When just a quick one for the multi-core rendering. And at which point does this work? Is this like within the application when you're trying to play it back, or when you're exporting? Could you explain like that bit again? Because people might be saying, "Oh, I'm rendering out. Is this that? Or I'm actually playing it back. Is that like that it renders the things that I'm about to play, or how does where does that slot in?"
So multi-frame rendering, it will do it anytime you are processing your composition. So playback, exporting, or the new the render ahead thing where it'll cache your stuff when you're idle. It uses that at that same time too. So pretty much anything, it will use multi-frame rendering. And I think some people might be a little confused if they've been using After Effects for a while, because there used to be a feature called render multiple frames simultaneously. That was removed in After Effects 2015, I think. So the people who've been using After Effects for a long time, they might remember that. And that was only on export. It did not impact when you hit play in your preview window. So I think that's kind of where that confusion is. Is this just the same thing they used to have and they just brought it back? No, this is a totally different thing, and it affects anything you do. Now, how much it impacts it varies a lot. If you have a relatively simple composition, it's just a lower thirds or something, it's probably not going to do almost anything. It's not really going to mean suddenly a Threadripper Pro is going to be way faster. It's just nah, it's the same stuff. It's still very lightly threaded. And even on those very heavy things, we still see that going beyond Ryzen or Intel Core usually isn't any benefit, because those CPUs have so many cores nowadays that you're getting up into it needs to be extremely well threaded to see a benefit, and they're faster on the per core performance. So even those things, even that multi-core score where we're testing specifically for this multi-frame feature that's supposed to make After Effects more threaded, even then, usually Intel Core is going to be the fastest thing. So it's one of those, it helps a lot, and it's made everything faster. Overnight, people were getting twice the performance, but they were getting twice the performance on a i5 CPU. So it's great, but from a hardware's perspective, it doesn't mean suddenly, hey, you can go out and buy a Threadripper Pro and it's going to give you a massive performance increase.
RAM, GPU, render, tracking, all those.
So the big three really are the RAM preview, render, and tracking. And those are what go into calculating the overall score. So RAM preview, it runs through all of our compositions. You hit spacebar, it plays, cool, how long did it take? And all of our tests are designed to be hard enough that no system is going to be able to play them in real time. Because if you can play something in real time, it is not really a good benchmark. Even though tons of real world projects you can do in real time. Well, maybe not tons, but some. But we need to have a bottleneck. So all of them, there's no way that they're going to be running in real time. So that's the RAM preview. Render, same thing, except we're going through the render queue. So we're just rendering out to, I think it's the default QuickTime preset. Usually the what you're exporting to, at least on our projects, doesn't matter as much. It can in the real world, but for our projects, they're hard enough that that's not the bottleneck. So that's basically what we're doing on those two. Is we're just going through, we're just doing RAM preview, we're rendering, we're exporting it out. Cool, very straightforward. Tracking is when we're doing a couple of different tracking. So camera tracking, warp stabilize, and then tracking a single point. Those, I will admit right now, they are ones that we possibly might have to drop in the future. I think they are super important. They're very single-threaded, but I think they are very important. But some of the recent versions of After Effects have been kind of squirrely with them. So hopefully we can fix that, because that'd be better to just fix it. But that's one of the things that we're kind of looking there. So tracking, as far as hardware goes, very single-threaded. Multiple cores isn't really going to help you as much. Doesn't need a lot of RAM. RAM preview and render, primarily single-threaded. Some of them we're starting to utilize that multi-frame rendering. So 8 cores, 12 cores is starting to give you a benefit. RAM usage there in our benchmark doesn't really matter. It doesn't matter as much for raw performance. Now, if you're in the real world, you're doing real work, RAM preview, especially, like the more RAM you have, it's just the more frames you can store in RAM. And so like if you have a really long timeline composition and you only have enough RAM to store half of that, well, then you're going to play through and it's going to stop. And then you're going to have to hit play again and it's going to be deleting all those frames as you go along. So when you're talking like a real workflow and a system you want to buy, that's where you want a lot of RAM, because you want to be able to play through your entire composition. You want to be able to jump back, because like you want to watch something multiple times. And hey, once you've gone through once, it's cached into RAM, so you can just play it in real time. And you can just view it in real time over and over. So RAM is...
What would you say is like the nice sweet spot of RAM capacity there?
So there's actually a math equation you can do if you want to know exactly, because it's basically how many pixels, like, so what's your resolution? How many pixels is that? How much RAM does that one frame need? And then how many frames are you going to be doing? So you can actually math out exactly how much RAM you want. And actually on our site, under our After Effects recommended systems, we have that formula right there. And so you can math it out exactly how much RAM you need. Generally, though, I will say that 64 gigs tends to be the minimum we do. I think 128 is probably like half of the systems we sell for After Effects have 128 gigs of RAM. And then maybe 10 or 15% have even more. And that's one of those situations actually where we do sell some Threadripper Pro systems, not for the CPU performance. In terms of raw performance, they are going to be slower in After Effects. But you can have a terabyte of RAM. And so for people that are doing crazy long and complex things in After Effects, it means that they can store all of that in RAM, and then they don't have to go back and re-render those frames that haven't changed. So the fact that it's slower isn't nearly as important as they just don't have to re-render those things. Because not rendering something is always going to be infinitely faster than having to render from scratch.
And I guess the Ryzen Threadripper 7000 is going to change that, because the single core performance now is going to be a lot faster than 5000. But I just want to have a question, like maybe more for like me, but some people as well might see that on the benchmark results. But I've tested the Ryzen 7000 and Intel 13th gen. There is a big difference in the tracking score of AMD CPUs compared to the Intel ones. Like even the Ryzen 5 7600X is about 50% faster than the 14900K in the tracking score. Is that the After Effects bug that you were talking about, even though single core should be much faster on the Intel one?
No, I don't think that's a bug. I think that's a real result. So one of the things with tracking, I guess just as an FYI, is that it has more run-to-run variance than a lot of the other things we test. And that's just a real run-to-run variance. You track something once, next time you track it, it might take 10% longer. So that's one of the few things in After Effects that we actually test multiple times. So each of those tracking tests, we do 3 times. And then I believe we take the fastest result because like that just tends to get the run-to-run result or variation way down. So that, again, is one of the things we test multiple times so that we remove that run-to-run variation. So what you're seeing should be a real thing. And I think that kind of stuff is where it comes down to not the clock speed, not the number of cores. It comes down to the architecture. And it's getting very detailed. And honestly, I can't tell you exactly why it runs better on AMD. Sometimes I'm not even sure if Adobe could tell you, because some of this code is very old and no one knows how it works anymore. But maybe they could tell us. It could be something like it's based on AVX 512 or AVX2. And so like those CPUs just have better performance there than an Intel. It could have to do with how it uses like L2 and L3 cache on the CPUs. Honestly, in my opinion, I often care less about the why than the what. Like I care that, yes, for that AMD is faster. Cool. Like if I knew why, that'd be great. But I care more that is what the truth is. And so for someone who's looking for a faster tracking performance, that's all they need to know is that is faster.
It's more helpful answer, I guess, than telling them why. Like, but tell me which one.
It'd be nice to know why.
Yeah, I mean, it will be. I'm the type of person who always wants to know, okay, why is it this? Because then maybe I can estimate or guess like some of the other things why it's working. Because, okay, if it was that, it might help me in the future. Is there anything else that you'd like to add for After Effects, or do you think you've pretty much covered it?
I think one of the big things with After Effects in particular, more than any of our other benchmarks, is that the raw performance is only one part of it, especially when it comes to the RAM and how much RAM you need. You might be better off sacrificing some performance to get more RAM, and that's better off than like a higher benchmark score. So benchmark scores are great. It is one piece of the puzzle. So don't get so laser focused on just that. Make sure you're considering everything else. Other than that, I think the only other thing we didn't really cover too much is GPU performance. Not nearly as big of a deal in After Effects as it is in Premiere Pro. Even if you are, for some reason, working with raw footage in After Effects, usually that's not the bottleneck. It's everything else going on in After Effects. So usually GPU is not as big of a deal. Oftentimes we are looking at how much video memory do you need. Cool, whatever GPU that's going to be. For a lot of our customers, that's going to be like a 4070. And that's good enough. You usually don't need more than that. At least not for After Effects itself. Once you start getting into plugins, then we're in a whole different world.
Do you want to explain a little bit more? The plugins, do they then use a lot of the GPU power or CPU power or just VRAM capacity? Is that what's important?
Yeah, I can touch on that. And plugins are going to be true for not just After Effects, but Premiere Pro, DaVinci Resolve. They're all over the place, to be honest. Like Boris FX, I think some of their stuff is very GPU accelerated. Some of it is pure CPU. Red Giant, same thing. Some are GPU, some are CPU. Some are coded very well, and so like scale very well with like a higher end GPU. Some are not coded as well, so they don't scale very well. So even if you see like 100% GPU usage, doesn't mean upgrading from your 2080 to a 4090 is going to give you a performance bump. It could be pretty similar. So that is actually one area that we want to expand more in the future. Not only is like, we'd love to test Avid, is a great example, but also, man, there's a big world there of Boris FX, Red Giant, all of these major plugins out there that people are using every day that behave very differently than base application. So that is one area too that we're looking at is, man, can we have a preset for After Effects? So we have our standard preset to test After Effects. Can we have a Boris FX preset? Can we have a Red Giant preset? And like, you would have to have the plugins, but if you have the plugins and you use them, you could run that and you can see how performance is on different CPUs and GPUs with those plugins. Because to be honest, it's not unusual that After Effects itself is not the bottleneck in real workflows. Sometimes it is those plugins, especially in After Effects.
We've got one more application now that is a little bit different from the rest, which is DaVinci Resolve, because it loves to use a lot of GPU. Like as much of GPU power I've seen, it like is awesome. And it actually scales on GPU power very well as well. Like adding second, third, I've tried even 4 cards. 4 cards wasn't as fast as 3, but I saw like unbelievable performance by just adding cards. Let's talk about the overall and standard scores. How like is there certain tests that you in here pull out as well? Is it like GPU effects, or is it literally 4K, 8K GPU and Fusion compiled? And could we touch that? Let's do that first, and then I'll ask this question.
Sure. Yeah, so I will preface this with saying that DaVinci Resolve is one of our next ones on our list of revamp. Premiere Pro and Photoshop, we just recently like revamped, updated them to like the latest, took everything we've learned over the last few years and updated them. DaVinci Resolve is going to be getting a lot of the same things we did in Premiere Pro. Actually, we'll be getting the same kind of thing. So we're going to be switching over our scoring to the same kind of codec based, LongGOP, Intraframe, RAW, same kind of deal. We will be able to add like Blackmagic RAW because that is natively supported in DaVinci Resolve, which will be great. So that kind of stuff in the future, I'm not sure exactly when that'll be happening, probably Q1 or Q2 in 2024. So then you'll be able to think of that very similar to how we're doing Premiere Pro, just with more of an emphasis on GPU. Today, how we're doing it is we have it split up into, like you mentioned, 4 different groups. Right now, it's split between 4K and 8K media. Turns out that, again, based on what we've learned over the last few years, that's not really the best way to divide it up for how like hardware is used. So even in our own articles, what we've started doing is pulling out the individual tests and generating our own like LongGOP score and Intraframe score. So like that's kind of a teaser of like why we're going to be making those changes. But right now, that is how it's divided up. So all of our 4K media tests, and that's everything from H.264 to ProRes to Red Raw is all in that bucket for 4K. Same thing for 8K. All we're doing is upping the resolution. And that 4K is included in both the standard and the extended preset. The 8K is only in the extended preset because you need a lot bigger of a GPU to even be able to do that. I believe our benchmark, we require a 10 gig GPU, I think is what we at least recommend for the extended preset, simply because in Resolve, when you work with 8K Red, you need that VRAM. And actually, in reality, like a real workflow where you have an entire timeline full of all these clips and you've got them layered. I just threw my pen. But in a real timeline where you have all your clips are layered, and you have multiple 8K Red clips, you need even more RAM than what our benchmark requires. In the real world, something like that, we'd say like, man, get a 24 gig GPU. So that's kind of like how those are right now are structured. It's just what is the resolution in every codec within that. Then we have GPU effects, which in Resolve are a lot bigger of a deal. There's a lot better noise reduction that's baked into Resolve that people are using all the time. All of the open effects stuff. There's so much more that is GPU accelerated in Resolve. And like you mentioned, it scales with higher end GPUs, multiple GPUs. Typically, we see it's diminishing returns, even just going from 1 to 2. Usually there's not much of a benefit of going beyond 3 anymore. So usually you just don't have a need for that. But it does scale better than any other nonlinear editor out there. So GPU effects are trying to test all of that kind of open effects, noise reduction, that kind of thing. And then we have also an addition that's beyond what we kind of would do in something like Premiere Pro is we have fusion tests. And in a lot of ways, you can think of that as After Effects. I mean, it's baked into Lightroom, or not Lightroom, it's baked into DaVinci Resolve, but it is for doing things like lower thirds, it's for doing VFX. A lot of the same stuff you could do in After Effects. Now, obviously very different, node-based versus layer-based, but general idea is kind of the same. So we test a lot of the same kind of things we're doing in After Effects in that fusion. A little bit more of a focus on things like lower thirds, because you're going to use it a lot more integrated that way, where you're actually doing it in there rather than exporting a file and then bring it in. So we have those fusion tests, and all 4 of those, the 4K, 8K, GPU-FX, and fusion, all go into generating that overall score, and all equally weighted. And so they all go together into that overall score. And GPU is going to be a lot bigger of a deal in DaVinci Resolve. Honestly, a lot of CPU, you can do a little bit more with higher core CPUs in DaVinci Resolve, which, I don't know. There's a lot of people who are like, well, DaVinci Resolve can use hardware a lot better than Premiere Pro because it can do multiple GPUs. It can use Threadripper. On the other hand, Premiere sometimes can do more with less. Like, you don't need a Threadripper. So it's one of those ones where, like, yes, it does use hardware, but sometimes you have to invest more in that hardware in order to start seeing those benefits of what it can do as far as like multi-GPUs, higher core count CPUs.
And another thing I have noticed when doing these benchmarks there is that the version of DaVinci Resolve often impacts the score quite a bit. Not as much on Premiere Pro, what I've seen, but in DaVinci Resolve is like massive in terms of like Fusion score, especially. I'm like updating to the 6 now, and I was like, Fusion score was so much higher that it just completely ruined like the previous version benchmark, because like they're not like comparable. Like in Premiere Pro, I could get like 23.6 and 23.5. They're like, you can still compare the benchmark results. But in DaVinci Resolve, it was massively different. Is there something that you'd like to add, or do you agree with this as well?
Yeah. I think there's a couple of things that are good points to make here. One is you do also have to be aware that DaVinci Resolve has 2 versions. They have a free version and a studio version, and those are not comparable. The free version doesn't have nearly as much like hardware decoding for H.264 and HEVC. I think it might have some, especially on Apple, might be a little bit different, but it doesn't have nearly as much. It also doesn't support multi-GPUs. So one of my favorite stories is there was another tech YouTuber reviewer, not you, and not someone I'm going to name, but they did some DaVinci Resolve testing. This was years ago, and they tested multi-GPU, and their conclusion was like, wow, well, Resolve doesn't use multi-GPU at all. It'd be a waste. But it's because they were using the free version of Resolve. Because they were like a general tech reviewer. They weren't actually like actual users of Resolve, so they had no idea. So they were just like, why would we pay for a license? We'll use the free version. And then it just made it like meaningless and just like misinformation. Again, it just like caused all of these people to quote this thing, and it was just wrong. So that's the biggest thing to be aware of. And even if you are looking for like comparing scores, you do have to be careful of that. Like I think most reviewers are going to be using Studio, or hopefully will be. But if you are someone just editing church videos and you're using DaVinci Resolve free, it might not line up. And that's actually one of the reasons why when people ask us for hardware upgrade advice, first thing we ask them is, hey, are you using the free version? If they say yes, we say, forget hardware, buy Studio. Like, that is going to get you more bang for your buck than a hardware upgrade. So that's the one thing with Resolve that is a little bit unique. The second thing, you were talking about versions. I don't think that's unique to DaVinci Resolve. We see that with Premiere Pro as well. Not the recent versions, but great example is Premiere Pro 23 is either 0.2 or 0.3 is when they added GPU decoding for ARRI. And for like a lot of people, made no difference whatsoever. For our benchmark, it changed it dramatically. It's one of the reasons why our current version of the benchmark doesn't support anything older than 23.2, because if you're using an older version, it throws off the scores too much that it's just like, it's not comparable at all. The other thing I'll mention is something that we have on our to-do list in 2024 as well, is to start grouping, at least on the public side, on our public result browser, start grouping things not only based on like what hardware you ran, but also based on either the benchmark and the application version. It'll be less important on the benchmark side, because once we hit 1.0 on all of these, like it's going to be stable. But especially on the application side, what we want to do is have, I don't know how many test beds, 2, 3, 4 of our test beds that just, all they do is they sit there and they have auto update on. And if they see that a new version of Premiere Pro was available, it installs it. And then it will rerun the benchmarks, run it like 5 times and compare it to a previous version. And then let us know like, hey, compared to the previous version that was out yesterday, this is like within the margin of error. It's within 5%. We don't have to worry about it. Cool. And then we can start watching for that. And anytime there is a new version that changes the scores, we can group that differently. So we can say like, I want to see results for Premiere Pro 23.2 through 24.8. And then you can see all those results. But anything after that has to be in a separate grouping. So that's a big job. It's something that I think we are one of the few people out there that has the resources and desire to do.
But also the need in a way, because to give that information to the client saying, look, I want this, or it's like, have you updated? Which version are you using? Because some people just stick in their workflow, I'll never update because it's going to go unstable and I know how this is. To give them that information, do you know what? Actually, if you updated this, you'd get 15% increase because that's how it works. You know, that would be massively important information.
And we do that for our own customers now. Like if we had a customer who told us they work with ARRI, when that update came out, we did an email blast. And like to everyone all of our customers that were tagged with Premiere Pro and ARRI, we let them know, hey, like don't obviously never update in the middle of a project, but you might want to check this out. It might make a really big difference for your workflow. Like, you know, install it side by side. If you're still on a previous major version, you can install multiple versions of Premiere Pro. Can't do that really with Resolve, but cool. But that only covers our own customers. Like that's a tiny fraction of Premiere Pro users. So this is something that we do want to do more and be able to publish that. And if there is a big update, we've done this in the past. Actually, the ARRI update, we even put out an article about it of saying like, hey, there's this update. We looked at it. This is what we saw. We saw something similar from DaVinci Resolve recently. They made updates to their neural engine. It was think it was like a 4x improvement for AMD, 2x for Nvidia. And so we said, like, that sounds nuts. Let's verify it. So we verified, and we're like, yeah, they weren't lying. Cool. It wasn't just marketing talk. So we do some of that, but we want to do more. And I think more than end users, that will be extremely valuable for reviewers, like yourself, like Inantech, Tom's Hardware, all those guys. Because a lot of those review sites like to keep old results and reuse them for as long as they possibly can. It's not something we do, but I understand why they do it. And if they knew, though, that, hey, this new version of Premiere changes everything, then it's like, okay, they need to make the decision. Do we continue using the legacy version and like they can keep using their old results, but it might not be quite as up to date? Maybe that's fine for what they're doing. Or it's like, all right, that means we need to redo everything because Adobe made things way faster and it makes all of those old results invalid. More information is never going to be a bad thing. Sometimes it's kind of a pain when you see those things and you're like, ah, man, I got to redo everything. But
oh, yeah.
Yeah.
There's been a few times where I'm like, oh, no, got to do that. But then there is the fine line where you think, do you know what, I think I'm going to stick with this for a while, you know, until the benchmark is supported, whatever. But then I'm going to change at some point because what happens with some of the channels, I think when you're bigger, you don't have to worry about it as much. But I don't have every single sample like just sent and keep. So I have to like perhaps send it back. It goes rotation. So I want to be able to get like a result that's locked in. I know I can use it even if I don't have the card, the CPU, whatever anymore. I can still use and compare this to, okay, this is that much faster. I don't have to retest it. So it's like valuable with that. And I can see why other people might do that as well.
Yeah. Well, and the other thing I think that keep in mind too is even if you are testing, say, an old version of Premiere, I don't think that's necessarily wrong. I mean, how many people, especially in like the professional space, who are going to be buying a $5,000 computer or doing a, you know, thinking about buying a 4090, they probably aren't on the latest version. Like they might be on Premiere Pro 22 or like some old version. That is extremely common. So I would even argue that there is some value in not always being on the latest. We've made the decision for our own content of always trying to test on the latest as long as there's not problems. But at the same time, you know, that's because we are always trying to look a little bit forward. We're trying to answer the question of like, where will things be for people in a year versus what is it now? So yeah, it's a balance. And ideally, I mean, I guess if it was an ideal world, we'd be testing every major version of Premiere and Photoshop, but like no one's got time for that, like at all. Like it's just impossible.
That's why I'd love, you know, to get your AI or whatever automated bench systems there that test it automatically and let us know all the results. That would be awesome.
And we do a lot of that. I mean, we do have, I think we have 14 test beds or 16 test beds that we always keep built up because I mean, we have a very unique situation where we are a system integrator and we do content and we do benchmark development. And so that's three different ways that we can get Intel or AMD to send us, you know, samples. We can get, oftentimes we'll get like a lot of motherboards from like a Zeus or Gigabyte because we're talking about carrying them in our product line. And that is a very different like way of getting samples than like for press. So we are, again, just unique in that we have like those three avenues that we can pursue resources. And so the more that we can do about like, hey, yeah, let's get those results out to people, the better. So same thing with like that checking versioning would be a great thing. We also have slated for 2024 to completely overhaul our public database because when you run our benchmark, if you have the free version, it automatically uploads the results into our database with just basic hardware information, nothing, you know, personal or anything like that, but it uploads it in our database. Right now, it's been, I think, like 2 years of, hey, let's get the minimum viable product up and then like we'll fix it and make it better later. That problem is anything with programming. That ends just being the semi-permanent solution. But this year is on our list of let's overhaul that make it better for people to search for results, compare results. If you're familiar with like Octane Bench's result browser, I'd love to have something like that, or like Blender's result browser. We're going to take, I'm sure, some cues from those. and just make it so that people in like your situation, Premiere Pro gets a major update, results are completely invalid. It's a major enough update that everyone is updating to it. No one's going to be on the old Premiere Pro anymore. At least then you could go into our database and see like, okay, for a 7950X, here's the mean benchmark result. Or you can filter it down to with this GPU or with this RAM, and hopefully you can find some things in there. Anytime you're dealing with a public database, you got to take things worth a little bit of grain of salt because you don't know, are they overclocking? Are they thermal throttled? Are they like, do they have 5 antiviruses running that are just like killing everything? But the nice thing with a database like ours is we're getting, I forget how many it is now, like 300 or 400 results a week uploaded into our database. So like there's a lot you can pull out of that noise when you have enough results. We also, on all of our systems that we're shipping out, we run all of our benchmarks, almost all. We run most of our benchmarks on every single system that goes out. So that is like clean data that people can look at. And we call it Puget certified results, where it's our own systems that we ran on. It could still be different because like we disable a lot of the auto overclocking that motherboards come with these days. So the scores might be a little bit lower than like what you might show or Linus Tech Tips might show or whatever, but at least it's clean. So hopefully that will help with those kind of things, making that database accessible to everybody, easy to search, so that if you don't have access to something, like you want to compare the M3 Apple stuff, hopefully you can just find some results in there and you can pull that out and say, yeah, it's from the Pugetbench database.
Listening to these numbers, I'm happy to hear and happy to confess that I populate that data quite a bit, especially recently when doing that. If you hear, say, a few hundred, I'm thinking, whoa, I've got a pretty big percentage there in the last 6 weeks. There's going to be a big percentage of my population. The way I'm doing it is I'm actually running each benchmark like 5 plus times as well to get like an average, just making sure that nothing was like dodgy to even minimize the error there. Is there any video and photo editing? I think photo we covered, but video editing softwares that you see a lot of your customers using that maybe we're not talking about, and maybe you can make a high score or like a table where Premiere Pro, I think that's what it's going to be, Premiere Pro, Resolve, Final Cut, and the rest down there. Is this what you see as well in terms of video editing software, or is there something else that we should be aware of? I know a lot of people ask me for Sony Vegas, but I don't think there's that many people there.
Yeah, so for us, Premiere Pro is definitely the number one application that we like work with and like we have customers for. DaVinci Resolve is very much second, and it is growing. I think we're seeing a lot of people either they're moving from Final Cut and they want to move to PC and they see Resolve and what they've been doing and are very excited about it, so they go with that. I think a lot of people are moving from Premiere Pro to Resolve or from Avid to Resolve. Blackmagic just has such a good thing going with it where it's a fully featured application. There's a free version.
One-time payment.
And one-time payment. I mean, our licenses that we're using, most of them are for Resolve 14. And they're fine. And we're on Resolve 18 now. Yeah. So, like, that's terrific.
And you get it free with the camera as well, which is ridiculous.
Yeah. And so, like, you can oftentimes pick up a license for, like, $100 because someone bought a camera and they're like, well, I already have Resolve. So they put the key up.
Yeah.
So, like, I don't know if that's technically legal. I don't know how that works, but, like, you can. But even without that, like, forget it. It's less than $300. It's a one-time payment. How many months of Premiere Pro does that equate to? Like, not a lot. It's a great
year
investment.
Almost. Yeah.
So Resolve is seeing a lot of growth. At least we're seeing a lot of growth and a lot of interest. They're doing a lot of cool stuff on like the AI side. Just everything about it. After that, Avid is probably our next one that we get the most requests for, Avid Media Composer. That one's a little bit weird in a few ways. One, we are not officially Avid certified, so people buying from us, it's not an officially Avid certified system. I think part of that is we're not international, and they prefer to certify international companies. So Dell, HP, Lenovo. But we still get a decent number of customers, and we get a decent number of people asking us for advice because they are going to buy Dell, but they want to make sure that they're buying the right thing. So we still consult with people even in those situations. After that, you start to get to things that aren't nearly as, like you said, not nearly as common. Sony Vegas probably is the next one. There's some, Final Cut, obviously would be much higher up there if we weren't PC, but since it's Apple only, we don't really do as much there. There's a few other small ones, but I really say like the top three really are Premiere Pro, DaVinci Resolve, and Media Composer. And those are probably going to be the three that we'll ever focus on for benchmarks, unless some other company like starts, taking off.
The other question I wanted to ask is about the RAM, which is how does that affect in these different applications? Like what I've noticed is compared to DaVinci Resolve and Premiere Pro, I've seen that the Premiere Pro is so much more RAM taxing than DaVinci Resolve. You can get away with much less RAM than Premiere Pro. And the other ones you mentioned, After Effects like to use a lot, Photoshop, Lightroom. Where would you say that also there's the RAM speed and the latency as well? Now, I don't want to go into the overclocking and XMP so much because that's a whole nother conversation, whether creators should be doing that, adding XMP over the IMC spec that comes with the CPU. But let's say like just how does these specs of RAM affect the performance in certain applications?
Sure. First thing I'll say is benchmarking. RAM isn't nearly as important as it is in the real world. So looking at a benchmark, whether it's Resolve or Premiere Pro, you're going to be using a lot less RAM than what a real world workflow will be. So RAM amounts is not something covered by a benchmark. I would say like any benchmark isn't really going to be covering how much RAM you need. That is very dependent on your workflow, how much stuff you're doing. Heck, like if Photoshop, it could be 16 gigs is fine, or you could have 10 images, giant images open, and now you need 10 times as much. And so it really comes down to workflow on these as far as like how much you need. I'd say on the photo side, a minimum these days is 32 gigs. On the video, it's probably more like 64. You can obviously get away with lower if you're only working with like HD or smaller stuff. But at least on our systems, that's kind of our starting point, just to give people like a frame of reference of like kind of what to make sure you're at least at. RAM speed is a very interesting one. We've done a lot of testing on that. We have plenty of articles about it. Generally, not important for these workflows, these kind of professional workflows in video and photo. Using 5200 megahertz RAM versus 6000 megahertz RAM, you're usually talking very low single-digit performance differences. So usually what we do is we stick to JEDEC timings, JEDEC frequencies. The exact frequency that is supported on the CPUs, we are starting to take a little bit of leeway on. It used to be Intel says it's this speed, we use that speed because like there was no benefit to going up. Now both Intel and AMD are very weird. Like okay, if you want to use one stick of RAM that's single channel, one DIMM per channel, and like all these other things, one single rank, you can go up to 5600 megahertz. But hey, if you want to use 4 sticks of RAM and they're going to be 16 gig sticks, it's like 4800 megahertz or 4200 megahertz. We can't really quite do that as much because we'd have to be carrying like 5 different sticks of, 5 different models of RAM for every CPU. Like we just can't do that. So these days, I think it is very safe to go ahead and either take whatever's in the middle or go ahead and go up to that upper range. As long as you're getting good quality RAM, it's usually okay to do that. It's always worth running mem test and doing all this other stuff. And if you have any performance or stability issues, that's usually the first thing we recommend people is like take that RAM frequency and turn it down a notch, see if anything changes. So generally RAM speed, you can take it to an extreme, of course, but is usually very low single-digit performance differences.
I just want to say a quick note, whoever's watching this, that I've got a full podcast with JJ from ASUS where we talk about the RAM frequencies, channels, timings, why is it going down when it's 4 sticks, 2 sticks, capacity is higher, lower, IMC, you know, silicon lottery, all of these things. So if you want to learn a little bit more why your XMP is not stable, for example, on AMD or Intel, go check that one out. There's a full podcast about that to actually understand how does this work. But what about the timings there in the application? Does that make a big difference in your experience or not?
You know, I don't know how detailed I can get. When we've done all of our RAM testing, we tend to stick to JEDEC specs. So like with JEDEC specs, it's here's the frequency and here's the timing you're supposed to use at that frequency. And so like they kind of move in lockstep. So we've done most of our testing with those together because that's what we would be using on our own workstations. Mm-hmm. So I don't know if I can really tell you whether timing or frequency is more important. All I can tell you is that between JEDEC 4800 and 5600, we see very minimal differences. I'd love to see someone do that level of testing, you know, nudge, nudge to you, because I think that's great information to know. But yeah, in general, just RAM, what we normally tell people is make sure your CPU supports it in some way and get enough. That usually those two things is the main thing we kind of like advise our users at least.
This was part one of this conversation. Actually, the conversation continued and we kept talking about Pugetsystems as a company and how they're doing a lot of things differently as an SI. So if you want to see that conversation, stick around. The video is coming out very, very soon. But for now, all you have to do is subscribe and hit that bell icon because then you won't miss the videos when they're uploaded. But you don't have to. You're welcome anytime and any day. Okay, I'll see you soon. Bye-bye.